Venari DevOps Edition is a distributed scanner for running dynamic application security tests. Venari provides fully automated, unattended scanning at scale, allowing companies to implement repeatable security test loops. These API-controllable tests easily drop into existing processes like CI/CD. The flexible node-based architecture makes it really easy to deploy scan capacity across Docker containers, virtual machines, cloud containers, or bare metal PCs. The scanners and the UI tools all run in Windows, Linux, or Mac environments. In this demo, we're going to implement the diagram that is shown on the screen, and it shows a scan cluster that has 5 scan nodes and 1 orchestrator node. This sample deployment is going to scan 3 applications at the same time. One of those applications will be scanned with 3 nodes in parallel to demonstrate the power and speed up that can be realized by using elastic scan. The other 2 will be scanned 1 job node to 1 web application. So 5 total nodes, 3 total web apps, and we're going to be doing elastic and 2 one-off scans at the same time. Prior to recording, I've downloaded from GitHub a copy of the Venari DevOps files needed to use Docker Compose to spin up a set of containers which we use as a scan cluster. I'm looking at Visual Studio Code right now, and in the code editor we can see there's a settings env that's important and a Docker Compose YAML file. The only thing I want to point out here is that we're going to spin up 5 job nodes, so I've changed this replica count from 1 to 5. I'm going to switch over to the Venari UI, and this is a copy of Ultimate Edition, which is the desktop product. It can connect to a remote orchestrator node when licensed to work with Venari DevOps. So I'm going to switch to this view, and we'll see some red toast pop up indicating that we don't actually have a server to connect to. So we don't have an orchestrator. So we're going to ignore this for now, and we're going to go over and actually spin the farm up. So what I need to do is go to my terminal and issue the compose command, and we'll see some text scroll by as Docker takes the images and creates containers. It'll be color-coded to show that there's multiple job nodes and there's the orchestrator or master node. So that stuff's spinning up nicely. So let's go back to Venari and let's go into our view where we were in remote and hit the refresh button. And we can now see that we're connected to a master. That's the orchestrator node right there. And that there are 5 job nodes that have randomly generated names. They're a combination of an adjective and a noun. But we're going to go back now and look in VS Code, and we can also confirm with this plugin that we have the Venari DevOps farm is up and running, and we've confirmed in the nodes view that we have the scan farm. So we're ready to do some scanning. And just to recap, we had a YAML file and a Docker Compose file from GitHub, and we ran a script to spin up 6 containers. One's the orchestrator node, 5 are job nodes, and we've verified that both in VS Code with the Docker plugin and also in Venari by looking at this nodes view. So in the next section, we're going to actually use these nodes to do some security scans. Now that the scan nodes and the controller node are running, we need to onboard some applications that we want to scan. So I'm going to show that on the home screen. We're going to go to this Actions menu, and we're going to pick Import and do a bulk import of 3 applications. So I'm going to pick the CSV extension, and I'll review this file in a minute. DevOps. I'm going to choose the templates we want. We only want to do an exploit scan, so we're not going to create the extra templates. We're going to click Finish, Create, and there are the applications. So now that they're there, I'm going to edit this Google firing range. It's a larger application, and I want to demonstrate elastic scanning, which is where you use more than 1 scan node to scan a big application kind of all at the same time. So we're going to make this one have 2 additional elastic nodes. So it's the 2 helpers plus the main node. So this one's going to have 3 scan nodes scanning this application, and the other 2 are just going to have 1 each by default. So I'm going to save this. I'm going to go back to the beginning, and I'm going to bulk run them. Try that again. Okay, so we select all of them, create it, and we run it. And in this screen here, we can hit refresh. And now that we see the little pause indicator, we know the applications are up and running. So let's take a quick look at what that CSV file contained It's basically a comma delimited list of the URL of the application, the name of the application, and then optionally the username and password if it's an authenticated scan. So I'm going to get this out of the way, and we're going to look at Google Firing Range. That's the one we tried to run with Elastic enabled. So when the summary comes up, I'm going to go over here to this area where shared job nodes actually has the number 2 next to it. And if I hover over it, we can see the additional 2 nodes that are actually helping out, and then this node name up here is the primary owner. So 3 scan nodes are already creating findings and vulnerability indicators over here, and we're going to go back and look at maybe one of the others. So DVWA and XVWA are also running, and these are kind of known vulnerable test web applications that are free to scan. If I look here, we can notice that there are no shared job nodes, so these guys are being scanned one at a time. So we've got 3 scans going, and one of them has 3 nodes cooperating on one application, which is Google Firing Range. So we're going to fast forward here and skip to the end of these scans and look at the findings, kind of review everything, and do some comparison of Elastic performance when you do it with just scan something with 1 node versus when we do it with 3. Kind of look at the time comparisons and comparison results in the next sections. Okay, so here we are in the all scans, all jobs view, and the scans I've completed. In the previous section, I set up 3 scans to run in parallel. One of them was this DVWA application. One of them was Google Firing Range, set up to run in Elastic mode with 3 job nodes collaborating on the scan, and the other was XVWA. So for purposes of comparison, I also queued up another scan after those were complete and ran Google Firing Range again. You can tell from this label over here that this is basically not Elastic, so I dialed the concurrency down from 3 job nodes to a single job node. If I do some quick math in my head, this minute 15 and 58 seconds is about 76 minutes, and down here the 3x scan ran at about 30 minutes, so that's about a 2.5 speed up for 3 concurrent scan nodes, so that's pretty good. Our testing has basically proven that you can get a linear speed up on some sites up to about 4 or 5 job nodes. Beyond that, sites tend to not be able to handle the load, or concurrency and I/O in the database kind of cause diminishing returns. But 5x nodes for 5x speed up is the ideal, and that's pretty good. So if we look at the findings count, we can see we got the same 178 findings in both. We can do a quick review just to show that the scan completed. This is the findings view. This is the same information in the summary view. So pretty happy with these results. Just to recap, we spun up a 5 job node farm using Docker Compose. We scanned 3 applications in parallel, where one of those applications was being scanned by 3 of the nodes. Then I repeated that scan again with just 1 node to make these comparative lines in the grid here. And that's a pretty good demonstration of the power of Elastic scanning and the power of concurrency. So I need to point out that the servers that we spun up using Docker all have REST API controls. The orchestrator node has REST API exposed that things like Jenkins and Bamboo or any custom build or CI/CD controller can use. So the fact that I ran this demo by clicking a button to start it is just kind of a simple way to visually demonstrate what's going on, but the real use case is to do that unattended on a schedule or on some kind of build trigger. So that's it. The last note I'd make is this is about a 4-year-old PC that I recorded this on. It's got 10 cores, so those 5 job nodes probably had 2 dedicated cores each. They each had 12 gigabyte of RAM available to them. Mileage is going to vary depending on how much hardware you allocate for these running Docker containers, but this could have just as been run on bare metal PCs or in VMs. It's very flexible. Venari DevOps runs on Linux, Windows, and Mac OS. So that's it. Hope you enjoyed the demo. You can get a free trial of Venari Ultimate Edition or the DevOps Edition by going to our website at the URL shown below and clicking on the demo or free trial button.